Okay, so the topic for today would be actually a quite trending topic, ChatGPT adoption, but in synergy with Arduino device. And we're building upon the story of Arduino R4 model with Wi-Fi integrated on board. And as we have access to the internet, it's quite convenient to try out this trending service, which is giving a set of new capabilities by its question answering power. So in this lecture, we'll see two examples, which are illustrated actually on this slide and also on the introductory slide as well. The main idea is that we uh, check out two scenarios. The first one is onboard ChatGPT invocation. So our Arduino device would actually be used as a client for ChatGPT service. So any kind of measurement or data recorded by Arduino device will be used in order to actually construct the so-called prompts to ChatGPT and send them directly using HTTP client and Wi-Fi access from our Arduino. So the response will be received back also on Arduino device, and we can make some decisioning based on the answer. In this particular example, I will be showing quite simple usage in hypothetical meteorological station or weather station, like based on Arduino, where we actually measure temperature or maybe humidity as well. And we insert that into a prompt which asks ChatGPT for advice which kind of clothes will be appropriate for this kind of weather, something like this. So it's quite simple example, but still illustrates how we can interact with this powerful service. So LLMs, the so-called large language models, are becoming quite popular in artificial intelligence area and now are the hottest topic to say. So since the end of 2022, by emergence of ChatGPT, initially developed by OpenAI organization, this area in artificial intelligence has become intensively explored by researchers and enthusiasts all over the world. As this was initially conversational agent, like a chatbot, which is able to provide answers to different kind of questions sent by user. And what was more interesting is actually that curiosity of ChatGPT's users has led to discovery of its full potential in many areas, not only in the so-called like shopping assistants or other types of to say substitutions for human customer support scenarios, but rather also for much more demanding tasks like in software engineering, like automated code generation, code analysis, giving advices for correcting code, identifying security flaws in the given code, and so on. So actually, this kind of approach based on a large language model trained on enormous amount of data is actually some kind of universal intelligence that can be used for solving different practical tasks. So we'll be actually exploring these two scenarios. So the first one is running client, like sending requests from Arduino as a client to ChatGPT. And the second one is actually leveraging the measurements coming from Arduino device within external scripts such as Python program and invoking ChatGPT from this external program, not from Arduino itself, but this kind of, to say, input such as sensor data from Arduino can be used for different purposes in that program as well, apart from construction of prompts. So some brief introduction to ChatGPT was already given. So it was publicly available as, to to say accessible service to users worldwide since the end of 2022. It has shown quite high versatility and adaptability in many areas, from creative writing and essay writing, story writing, and lyrics writing, even poetry, to programming, code generation, and data analysis, like basic machine learning tasks. It's also possible to perform all this stuff using ChatGPT. Two, even some entertainment purposes, like playing, acting as agent in some simple board games as well. So the underlying mechanism is based on large language model, which is leveraging transfer-like customized method, which combines both supervised and reinforcement learning. And it was trained, the initial version of ChatGPT, which was publicly available, was trained on almost whole web archive, all the publicly available textual data from World Wide Web up to 2021, which is enormous amount of data, which is actually explanation why it's so powerful and able to answer the questions on any topic. So there are two main modes of usage. It's important for the rest of the showcase of the examples, as I'll be having some tokens inside my code, which are actually coming from registration on OpenAI website. In free mode, we can use it only by graphically enabled interactive web application, like the basic ChatGPT. The most known form of ChatGPT is the one where we pose questions to the chatbot and receive the answers. On the other side, the other mode, which is more more suitable for this particular topic today, is programmatical access to ChatGPT service using either some specific library, client library for Arduino. There is a library, but in the end, I will be using basic HTTP requests as due to some compatibility issues, but there are clients for all the common programming languages like Python, JavaScript, and so on. When it comes to limitations, user-provided input question at the moment, when I initially was trying out this idea like last year, it was up to 3,000 words. And another thing that needs to be taken into account all the time while you actually use any kind of ChatGPT related services provided by OpenAI in programmatic mode, we need access provided by token that we get by registering on the website, and also providing payment information, which might be problematic in some scenarios, but if we have a lot of automatic prompts to their services, it might cause some additional costs. Like in this particular example, I'll be having like several tens of requests, which won't cost much, not more than $1, but as you see, it's $0.02 per 1,000 request tokens. It can be translated to several hundred of words maybe, but it's still not much. But if we put this script to run all the time in the background and connect Arduino to send a lot of requests to ChatGPT, it can cause some inconvenient costs. So I'll be using one of the latest, not maybe the latest, but one of the later ChatGPT models, which is quite powerful in question answering. But before that, we need to install some dependencies in Arduino IDE. Particularly, we need to include Arduino HTTP client library, as this one is prerequisite for creating secure HTTP requests as required by OpenAI services, as they need also to include authorization by token that we get from the website. So when it comes to this aspect, we need to make sure that all the stuff is already installed when it comes to Arduino R4. It's assumed that it's already done before, but here when it comes to managing libraries, we'll need to find Arduino HTTP client library and install it in our IDE. I hope that this window is opened. It caused some slowdown, but it will be open at some point. The other aspect that needs to be taken into account as we need OpenAI token is actually creation of OpenAI account and including of billing information like credit card number. So it can be done. Okay, so I here can now try to find Arduino HTTP client library by typing Arduino HTTP client. I already installed this library, but we can check it out as well. Apart from this library, as I said, we need a token which can be found on OpenAI's website, but we need to first register and set up the token. So when we open this link, we'll have ability to actually create new secret key, which is actually the token that we'll use. And once we generate this secret key, we need to write it down and we can further use it for our program. So we click here on this create new secret key. It will be generated and we can copy it to the clipboard and then paste it into the application. We can save our key afterwards, which is convenient for our scripts to be used inside them later. And now let's consider the first scenario. It's direct ChatGPT access from Arduino script. And okay, this is the window of HTTP client. We can try to find it as this manager of libraries is quite slow when we search for new ones, as it's fetching them from the online repository at the same time. Once we have the key, we can start implementing the script for programmatic access to ChatGPT services, which is relying on this Arduino HTTP client. As I already installed it, let me see. It's still browsing the available libraries, and it's quite slow. But I hope it will be unblocked in several seconds. Okay, this is the library that we need, and we need just to click install. As I already have it installed, I don't need to do that again. So we can close then the window with library manager and proceed to the code itself. So what's interesting here, we need to include some headers. Arduino.h, Wi-Fi S3, which is for the underlying ESP32 chip on Arduino R4 board. So we have also this Wi-Fi SSL client included. And I'm not sure if this one is actually, yeah, it's actually used as like secure Wi-Fi client for authorization enabled, authentication enabled HTTP requests, including the tokens provided from OpenAI. And we need to include, of course, the previously mentioned HTTP client library and JSON.h. In case that it's not available, we can also include this library as well or install it. If there is any problem including this library, we just type Arduino JSON and install it. But I think it should be available already. So these are the set of library. This is actually the set of libraries that we need to include before proceeding, before any like writing of the ChatGPT invoking code. So this one has to be installed manually. And this Arduino JSON library is like additional library, which would make our lives easier by incorporating more convenient access to JSON objects which are both the requests that we send to HTTP client for ChatGPT service, like putting the prompt itself and some other optional information like a randomness factor of the model and selecting the model version itself. And on the other side, the answer that we get is going to be also in JSON format, so we can extract the actual payload from it quite conveniently. When it comes to auxiliary variables, we have SSID, which is the name of our network. This is the name of my network from mobile device. This is the password. We need to provide OpenAI key, as I will invalidate this one after the meeting, as it should not be publicly exposed. We have the string for the answer and this Wi-Fi SSL client object, which is actually used for to say secure HTTP requests. And what we would actually create on top of this Wi-Fi SSL client is HTTP client, the one which is using Wi-Fi connection for secure HTTP authentication enabled requests using the token to api.openai.com website on port 443 for SSL. This is what we need to construct, like this HTTP client object, which is making use of Wi-Fi client object for Wi-Fi access, and afterwards we define secure HTTP client connection. In the setup, we only have initialization of terminal, starting the Wi-Fi connection for the provided network and password, checking the status of the chip. If it's already connected, then we proceed. Otherwise, we wait for the connection to happen. When it comes furthermore to, okay, so this is the structure of the program in general. In the setup, we connect to Wi-Fi as in this extract of code. We also have several more crucial parts of the code emphasized here. So let's go to the code. In the loop itself, what we have? We have random generation of temperature values simulating the sensor measurement up to 35 integer number. And we print the result. We have the question what to wear if temperature is. And we put this generated value inside the prompt by concatenating the string to the question. So we concatenate this integer value as a string to the question string. So we get the whole question that will be submitted to ChatGPT. Moreover, we have this part of the code forming the payload as a JSON object, and it actually consists of the fields which are required for ChatGPT in order to generate the answer. We have JSON object, which has model. We select the appropriate model version. In this case, it will be not the latest, but 3.5 turbo. There is also version 4. Temperature is like answer randomness factor. It's add some variety to the model, inference mode of the model, like it will change the words, not only give the same answer all the time for like some kind of initialization of randomness seed that would affect the answers length and variation. When it comes to the role, it's like point of view in conversation. So we, from which point of view we actually post the question, we will be doing it as user, not as a system, as we can also switch the roles in the multi-agent conversation, like system, like the perspective of ChatGPT and user, someone asking it. The content field, as you see in the message object, is the question itself. So we just put the previously created string. And in the end, we actually serialize this JSON object in a request body, and then we use it further for HTTP request. In this HTTP request, we use the previously defined HTTP client object. We begin the request, and we create post request by saying, like we initialized creation by saying begin request, then we say post, and put the endpoint of the service. It's V1 chat completions, the endpoint of OpenAI's ChatGPT service, which is available online. We define the header. Content type should be application JSON. Authorization should include actually here our OpenAI token. We define the content length, which is equal to the request body length, and it's based on the JSON object, which is serialized for transferring over HTTP. We begin the body, we put the request body and end the request to finalize HTTP request. So this is actual code. I put on slides the most important parts. We begin HTTP request, but this is the HTTP client that you can see here. I created over Wi-Fi. We define the send handler, we define the body. The request body itself is serialized JSON document that we actually used by defining it here. And now we can actually, we have this messages and message object. We create nested object, which is actually inserted to the array of messages. So all this is actually inside the JSON document. We create dynamic JSON document, which can be additionally extended and its structure modified. So we here define these fields, then we create this nested array of elements, and our particular message object is the one containing the question, and it's appended to this nested object, which is part of the raw JSON document. So this is how the message is created. So this one resides inside messages, but messages reside inside JSON doc. And here we serialize this JSON doc to a request body. Here we execute HTTP request from the client, get the status code and the response body. And we have another JSON document, which is for the response this time, not for the request. We perform now deserialization of the document. Like the response is put in JSON form into JSON doc.i, which is auxiliary object, temporary object. We iterate using JSON array object the choices, like some possible answers provided by ChatGPT as a response. As JSON array, for each loop, we traverse the array. We get each of the messages as JSON object. We take its message field as JSON object. We ask if the role of the message is assistant, like from perspective of point of like chat assistant, like bot which helps us get the answers. So we can extract finally the answer from the message, which is the content field from the JSON object, and we convert it to string. So we can actually get this value as answer string and print it out in the terminal. And we have some delay in order to avoid the rapid sending of these requests. I can now connect my Arduino device and we can see how it works. I'll need to define my COM port. Okay, it's the appropriate one. I'll verify and compile first the code and then upload it to my Arduino device on COM14 port, serial port. And now let's see. Okay, compiling has started. Once it's completed, I can upload it directly to the device. I'll make sure that my mobile device is sharing a Wi-Fi hotspot so I can connect from my Arduino to my mobile phone. The compiling is completed. I can upload it to my Arduino device. It's checking for recompilation, but it should detect that everything is already compiled. Okay, so now it's transferring it to the flash memory of Arduino. I can open the serial monitor and see what's happening over there. It's connected to Wi-Fi network. It generated 18 as a temperature. What to wear if temperature is 18? And the answer is at a temperature of 18 degrees, you may want to wear a light jacket or sweater or t-shirt. Maybe it depends actually also other factors, whether it's rainy or no. I haven't included other parameter as humidity, but it's like simulated, not coming from real sensor. What to wear if it's 23? Clothing such as t-shirt, it's reasonable for 23, so the answer seems quite like expected. For 7, it's quite cold. Layered clothing such as thermal top, sweater, and jacket to stay warm. Okay, it seems that it's working correctly. And now I will disconnect my Arduino device in order to make sure it won't send more requests and cause some charges for the service usage. And now here is additional explanation of how the code for sending like sending the request works, and also here how the answer is handled and extracted from the message, from the response, which is deserialized JSON answer from the service. And the relevant fields like role of the message, information about role, and the extracted answer, which is message content field. The second example is using Python script as on host PC on my laptop to access actually the sensor data from Arduino, but over serial terminal, not directly from the sensor of the device. But I'll be using terminal as a mean for exchange of the data between Arduino and my host PC. So what I will have here, I will have actually Arduino, which will be generating again random value up to 35, which is printed to a serial terminal. On the other side, host PC running Python script would be getting this value, inserting it into the question sent to ChatGPT, and sending this request using OpenAI library for Python, defining the model. The message itself you see as a JSON object in a similar manner as we saw for Arduino. We define role, we define content, which is the question itself. And we insert here the line, which is actually the value coming from Arduino. For when it comes to dependencies, we need to import serial library in Python. We would need to install it if we don't have it already in our environment. Pip install serial is the command to install it. So also we need probably to install OpenAI library for Python as well. So there are many ways actually to do that if it's not already installed. But now let's see what is actually provided. Okay, and finally in the responses, we when we handle the answer, we have this advice variable, which is taking the choice 0, the first choice coming from the message content of the answer. So let's see now this example, which is here. Arduino Python is the code that I need to run on my Arduino device, and it won't interact actually with ChatGPT itself. It will be only sending some randomly generated values, some data to ChatGPT, and this is an auxiliary script in Python, which is invoking ChatGPT prompting by inserting the value coming from Arduino. So now I open both my Arduino's part, which will be uploaded to the device on port 14. So this serial terminal is important to be included here in both the Python script as a library and in Arduino's code to actually be used as a means for sending this by println of the value. On the other side, this is the script. I use client OpenAI client library. I define API key I define serial communication object on particular, on some specific port, which I can select here. My device is connected on USB port, which corresponds to virtual COM14 port. The bitrate should be matching with this one. And what we have in while loop, we read by this line the data from serial terminal coming from Arduino, decoding using UTF-8. And we say Arduino says it's actually the data coming from Arduino. Then we insert the line in the prompt, which will be sent to ChatGPT. And otherwise is actually the answer that we get from ChatGPT. And the choice 0 is the first answer that we get, and its message content is printed out as well. So I'm running the code on Arduino now. I compiled it, now I can upload it. And on the other side, I'll need to also open this code in Python and run it. Probably it's better that I first start the Arduino part. Okay, it's generating 18 as a value. As for now, I will say, okay, the command to run is Python 3. The script itself is Arduino laptop. I run the script. So now there is some problem with the communication port. Let's try it out. Maybe I would need actually to first do it in other order. So I can maybe disconnect Arduino. First start this one. Okay, maybe the order of starting this was wrong. So let's try out again. So okay, let's try it out. This is the Arduino's part. Again, let's see what cannot file specified. Some problem is preventing the program on Arduino in Python to find the port. Okay, it's not now connected. I will put it back on the port. But maybe the better idea would be that I connected it. It's now transferred the data. I will disconnect it again, connect it, and try to find it on the port 14. Okay, so now it seems to be working. And yeah, so first we need to start the Python script and then connect Arduino with this program already in the memory. So you see now that Python program is actually handling the prompting and inserting this value to the prompt and getting the responses, printing them out here. So yeah, the order was a bit different. We need to transfer the program, disconnect Arduino, then open Python script, then connect Arduino with already loaded program on our computer, and the Python script will identify once the data starts to be exchanged from our Arduino device. Now, the problem is that we cannot at the same time debug the port communication in both Arduino and Python environment, but it's generating the data that is being transferred to Python. But we cannot see it at the same time here, as port is already in use by this Python program. Okay, so that's it that I wanted to show to you today. Let's see. No, there are no more slides. I can now disconnect my Arduino. Okay.